Hello everyone, this is Himabindu from the Department of CSIT. Today in this video, I would like to explain the designing the regular expressions. So till now we have seen that what is meant by regular expression and how it is formed, and what are the regular languages and what are the regular sets, what is the difference between the regular set and regular languages and regular expressions. Now in this video, I would like to explain about the designing of the regular expressions. Let's move on to the slides. So here this designing the regular expression, we have three types. So one is regular expression from the given languages, and we have a regular expression for a given NFA and regular expression for given DFA. So we design the regular expression according to the languages and what is the finite automata, whether it is an NFA or DFA or epsilon NFA, we will design that regular expression from the finite automata. Designing the regular expression for the given languages. So here we have taken some three examples of languages. So what are the languages in the sense? The first language accepting the strings of any number of A's and B's. So let's write the language for this one. So language is equal to, so what is the statement says that the strings of any number of A's and any number of A's and B's. So any number of A's and B's in the sense, so any number of A's or B's or AB, BA and AAB, BBA and so on. So any number of A's and B's. So how to construct a regular expression for this kind of languages in the sense? So either it is starting with A or B. So how we will define the string which is defined is any number of A's and B's. So the string contains any number of A's and B's, like, so it is going to be start with either A or B. So either A or B, it is going to be defined as A plus B. So either the string is going to be start with A, or the string is going to be start with B, or the string is going to be end with A, or the string is going to be end with B. So there is no limitation of such kind of things. So it is the strings which are any number of A's and B's. So how the string is formed as a regular expression. So either it is starting with A or B and whole star. So whole star represent, so either it is starting with epsilon symbol also, the string, and so epsilon B, this is one kind of situation, and epsilon comma A. So for this one, the string is going to be start with only B and the string is going to be start with only A. This kind of situation we will write. So epsilon is also included. So epsilon is also included in the string in the sense that is denoted by the whole star representation. So in the previous video, we discussed that whole star and plus differences. Let me write what is the difference between the whole star and A star and B plus. We will say that B plus. So A star, it contains empty symbol also, and A, like that. A, many times of A. And for this B plus is equal to, so it is not including the epsilon symbol. So I am not writing any epsilon symbol here. B, BB, BBB and so on. So here it is the difference. The epsilon is included in the star symbol and in plus symbol epsilon is not included. So that is the difference between star and plus. So here what is the regular expression for this kind of languages in the sense? A plus B whole star. And next one. So next language is about the string with starting with AB as a substring. So AB as a substring, the language says that the AB as a substring, there is no limitation of starting and ending. So we can form the languages with the starting of A, either A or B. So just now we discussed the string is going to be either starts with either A or B, denoted as A plus B whole star. So how this language is written as a regular expression. So here the substring A must be there. So A, B. So here the AB string is must be there. And for this one, there is a no limitation of starting and ending. So I am writing this. The string is going to be either starts with A or B. And there is a no limitation of the string is going to be start with end with A or B. So that is denoted as the substring is going to be starting with either A or B, and this substring AB is ending with either A or B, denoted like this. And this is the regular expression. What is the regular expression for the language accepting the string with the substring AB, in the sense A plus B whole star, AB as a substring and ending with either A or B. And next, language accepting the string of length exactly 2. So how we will denote this language? We just first elaborate the language first. Later we will design the regular expression for this languages. So what is the length? Minimum length. So here we are all, the language is formed with the input symbol A comma B. So the minimum length of exactly for this string language is exactly 2. So how we will form with these two input symbols? Let's write the language first. So what is the strings language accepting the strings of length exactly 2. So exactly 2, in the sense how we can form that exactly 2? AB, AA. So there is exactly, they said only exactly 2. So there is a no limitation of like the string should be start with either A or B. So that's why I am writing what are the possibilities of the length exactly 2. We will write BB. And this is the language. So there is a no multiple times or only A should be written like this. So this is exactly 2 length of the forming with the AB symbols. So for this one regular expression, so how we will write? So the language contain all these four strings. So how we will find this one? AB plus AA plus BA plus B. So here is the regular expression. So we will simplify this regular expression. So how we will simplify, in the sense just taking the A from this 2. So taking A as a common, what is the next thing? B plus A is left there, and B plus BA plus BB. And here also we will take B as a common, A plus B. And we will take, so write A comma B. And we will take off this A plus B and A plus B. So here the exactly 2 length, it is A plus B 2 times. And if it is exactly 3 lengths, one more A plus B is there. So that is the how we are forming the regular expressions from the given regular languages. And next, and here we have designing the regular expression for the given NFA. So given NFA, here is the example of one NFA. So we already said that what is the difference between the NFA and DFA. So for the same input, if it is reaching the same state multiple times, it is a NFA. For the single input, it is reaching the single state, it is called a DFA. And here we are starting as a Q1. For defining the regular expression from the given NFA, we starts with the incoming edges of every state. So let's find. We have to solve the final state equation first. So for what are the equations for this NFA in the sense? So Q3, from Q3, what are the incoming edges? What are the incoming edges like input edges are there? We have to write that. So what are the incoming edges for this Q3 state in the sense? From Q2 it is coming with input A, and no more other incoming edges for the this kind of incoming edges are like this. So incoming edges only one for Q3. And next equation, so we have to form the equation for the Q2. So how we will define that Q2 equation? So what are the incoming edges for Q2 in the sense? And here from Q1, let's start with Q1. So Q1A plus, and here Q2B plus, and one more is there plus Q3 from here B. So let's name it as 1 equation and 2 equation, and write third equation. Q1 is equal to, so here the starting state, Q1 is the starting state, so we will write a nothing symbol also, like epsilon symbol. And what are the incoming edges for the Q1 state? So Q1 itself with the input symbol A, and Q2, Q2B. So no more other incoming edges for the Q1. Let's name it as a third equation. And first solve the final state equation. What is the final state here? The Q3 is the final state. So let's solve this Q3 equation. So Q3 is equal to what is the Q3? Q2A. So let's solve this one. So how we already have this equation. So what is the Q2 is having the values in the sense, we have to substitute all these values into this Q3 equation. So here I will write substitute Q2 in Q3. So here what is the Q2 value? So Q1A plus Q2B plus Q3B, and A input symbol. So elaborate this, AA plus Q2BA plus Q3BA. So here it is the equation we can't solve. And next move to the equation number 2. So what is the equation number 2? And we will substitute this Q3 value. So we have already Q3 value, so we will substitute that Q3 value. So what is the equation first? QA, Q2B plus Q3B. So 1 in 2. We have to submit 1 in 2. So we will write Q1A, Q2B plus, what is the Q3 value? So Q3 value is equal to Q2AB. So Q1A plus Q2B plus Q2AB. So here we will take common Q1A plus Q2 and B plus AB is there. So Q2 is equal to. So according to the Arden's theorem, R is equal to Q plus RP. So here by using this Arden's theorem equation, we will solve this one. So these equations, these finite automata is converted to the regular expression by using the identities and Arden's theorem. So identities and Arden's theorem already discussed in the previous videos. You can refer for this simplification. So for here according to the Arden's theorem, Q plus RP is equal to QP star. So this is the equation. So we will convert this equation. If it is the equation, it is in the form, we will write like this. And what is the equation contains? Q2 is equal to, so here this is a Q, we will write here. So Q2 is equal to Q1A plus Q2B plus AB. So how it is looking? This one is Q. If you consider this is a Q plus R. So here R should be common. R is equal to P. So this is a P. So how we have to solve in the sense Q2 is the R is equal to QP star. So Q we are writing like this, Q plus RP star, RP is equal to P. So P is here nothing but AB plus AB star. So here how we have solved this Q2 equation in the sense, so by using the Adam's theorem, R is equal to QP star, we will define this one. And fifth equation. So we solved till now, we have solved the Q2 equation, and we will move to the Q1 equation. So what the Q1 equation contains? Q1 is equal to epsilon plus Q1A plus Q2B. Q1A plus Q2B. So as we already got the Q2 equation, let's substitute this Q1 equation. So Q2 is equal to Q1A. Epsilon plus Q1A plus Q2 is equal to Q1A AB B plus AB star. And B. So how to solve in the sense? So epsilon plus Q1A plus Q1 AB plus AB whole star B. So let's take off this common Q1 state, A plus so here again we form the equation R is equal to Q plus RP. So it is R is equal Q, and here this is R and this is P. So what is here? R. So how it is? Q1 is equal to, how we have to, using Arden's theorem, R is equal to QP star. So QP star, so epsilon, so Q as it is we are writing, and we have to write this A B plus AB plus whole star B and whole star. So as we already know, epsilon R star is equal to epsilon, R star. So according to the identities of regular expression, we will form this equation. So epsilon is removed. So A plus A B AB whole star B whole star. So this is the equation 1. So what we have to do first, we have to solve the equation number 3. So what is the final state here? We have to solve that equation. So we have only the Q1 equation. We will substitute this Q1 equation in the Q3. So here it is the Q3. Q3 is equal to A plus A B plus AB whole star B whole star A B plus AB whole star A. So this is how we have formed the regular expression for the given NFA. And next, so design a regular expression for the given DFA. So designing the regular expression for the DFA, in the sense we will take one DFA diagram, transition diagram, and let's draw this one. So we are taking the initial state and as well as the final state, and with the input symbols A comma B. So what is that equation? What is the diagram contains? So Q2 and 4 states we are taking, Q3 and Q4. So for the input symbol A, it is going to. So this is the transition diagram for the NFA, given NFA. Let's convert this DFA into a regular expression. So as we already discussed, if you give any finite automata, we have to convert that into equations. So according to the incoming edges from the states. So let's solve these equations. So here what is the initial state and final states are same. So we are taking the Q0 is equal to, Q1 is equal to, so Q1 incoming edges are, what are the Q1 incoming edges? 2 are there. So Q2 plus Q2 with B input and Q3 with A input. So this is equation number 1 and Q2. So for the Q2 equation, so only one incoming edges are there. So from the Q1 it is A, and for the Q3 state only one incoming edge from the Q1. So Q1 B and Q4. So what are the incoming edges? So we have the incoming edges for Q2 with A input plus Q3 with B input and 2 inputs for the same state. So QA, Q4A, Q4B. So these are all the equations formed from the given DFA. So let's solve this first. This is the final state and initial state. So we have to solve that equation. So what is that equation contains? We have to substitute any values. So Q1 is equal to Q2B plus Q3A. So we already know that Q2 and Q3. So we will substitute 2 and 3 in 1. So Q2 is equal to Q1A B plus Q3 value Q1B A. So Q1AB plus Q1BA. So by taking the Q1 as a common, Q1AB plus BA. And here, so what is this equation contains? Epsilon. We will also include one more point what we have to do. So here it is a starting symbol. So we have to include epsilon symbol also. I forgot. So epsilon plus epsilon plus epsilon plus epsilon plus. So here it is in the equation is in the form of R is equal to Q plus RP. So according to this equation, R is equal to QP star we have to write. So R is equal to Q1 and Q is equal to, and this is the P. So according to the Adam's theorem, what is the equation contains? Epsilon AB plus BA whole star. So epsilon R star is equal to R star. So according to the identities, we will get the equation Q1 is equal to AB plus BA whole star. So we solve the equation for the final state. So this is the regular expression for this given DFA. So, and we till now we have seen the regular expression constructed from the single final states. Let's construct a multiple final states with the DFA which is having the multiple final states. So the DFA with multiple final states. So what DFA with final multiple states in the sense. So first to draw this final state. So I am taking the Q0 as the initial state and it is also a final state Q1 and Q2. So with the two final states and Q3. So here we have taken the two final states. So it is a multiple final states for the single DFA. So this is the multiple final states with the DFA. Let's construct a regular expression. So till now what we have seen the how we found the regular expression from the finite automata. So what we have to do for multiple final states in the finite automata, we have to union those two equations. So here in this equation, in this diagram, transition diagram, we have two final states. So what is the final state? So Q1 and it is also a starting state. So I am going to include epsilon symbol to this one and Q1 incoming. What are the incoming edges for the Q1 state in the sense 0 and only one state. And so and let's solve another equation. The Q2 it is a final state. So what are the incoming edges? So from Q1 it is coming with the input 1 and Q2 it is self. So with the input 1. And for the Q3 state, so incoming edges coming from the Q2 with the input symbol 1 and Q3 0 plus Q3 1. So here are the equations. We have to solve this 1 and 2. So 1 and 2. So what is this 1? And we have to combine these equations Q1 union Q2. After solving the equation, we have to get the union operation. We will get the regular expression for the multiple final states of DFA. Final states of DFA. And here, so how to solve this equation? The first equation we have to start with Q1. Q1 is equal to epsilon plus Q1 0. And so epsilon plus, as we already know, that R is equal to QP star. Q or P is equal to QP star. So it is in the form of equation. So here it is a Q, R and these are the R and this is the P. So after solving this one, what we will get? Epsilon 0 star. So epsilon 0 star is equal to 0 star. So this is Q1 is equal to 0 star. So this is the fourth equation. So what is the fourth equation? So fourth equation contains 0 star. And Q1 value we already got. And what is the next step? Q2 we have to solve. Q2 is equal to Q1 1, Q2 1. So let's write this Q1 in. So Q1 4 in 2. So Q1 value is equal to 0 star 1 plus Q2. So after taking common of, so here we got this Q2 and what will we get? So here it is. So here it is in the form of Q and R P. So how we will get? What is the equation for the Q2 is equal to 0 star 1 with 1 whole star. So here this is the equation. Q2 is equal to 0 star 1 1 whole star. So this is P. and here it is the equation. Fine, we have to solve. We solved, and here we got the two Q2 and Q1. So what we have to combine those two states. Why? Because two final states are there for the single DFA. So we have to solve that one. So Q1 union Q2. So what is that Q1 and Q2? 0 star union 0 star 1 1 whole star. And here plus we will include plus 0 star 1 1 star. So after taking off 0 star common, epsilon plus 1 1 whole star. So according to the identity rules, epsilon plus, here we will write epsilon plus r star is equal to r star. So here 0 star 1 star. So finally, what is the regular expression for this multiple final states of DFA, in the sense our regular expression 0 star 1 star. And these are the references. What are the examples till now we have discussed? Those are taken from these sites. So here it is the designing the regular expressions from the given finite automata. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.